to the number 3 subchapter, talking about how to solve our equation. So that we have learned define symbolic operations, and working with expressions. Now we put the expression equal to 0, then that it will become equation. Then let's doing the way to solve that. In the mind map is I put the sample one. So when we do the equation solving, we will need this solve the class to be import from the SymPy library, and you can see the syntax. Using the symbol, we define x as our symbol, and we make our expression a simple expression. Then use this solve function to do this expression. Then we will get this expression's value for x. The assumption here is we will assume the this expression equal to 0. Then that means is x minus 5 minus 7 equal to 0. Then solve will give us what the value is x, which is the 5 plus 7, x equal to 12. So, and then we will use this solve mechanism to do the quadratic equations solving practice, and also solve our for one variable in terms of others. If one expression has multiple the variables, we can point out which variable we want to have the solving result. And also we will solve our system of linear equations. So two equations altogether with two variables, x and y, then we can have x and y's solving result. So we don't have the specific the coding need to be put is here as a Python, so we only use the terminal here. So let's come to Python and start to practice. So this is a solve function used to find a solution for equation. So now the expression is the equation. So we will from the SymPy import symbol and also this solve. And then we have x is the symbol x. And we define our expression equal to x minus 5 minus 7. Then expression, let's see, is they have this simplified to this x minus 12. Then we will do the solve express. Then they will give us a list. You see this square, the brackets, so within the 12, then that means that here is a list. Because this x has our unique result. But if I put this x is equal, expression is equal to x squared 2 minus 5 times x minus 2. So that is the quadratic equation. Then for this, you know, it's x should have two results. So same as let's do the solve. You have this list, and the first is the value 1. Here you can see is 5 second minus the square roots 53 and divided by 2. Another is the plus. Just the signal is the difference. So that is the two values. So when we use this solve, just bear in mind is we will assume this is a value equal to 0, which means the right part is equal to 0. That we call the equation. And no matter you put is what are the expressions here, the Python will calculate that and give you the result. So we already practiced this. So when we see here is already just to give you our list. But if we put that is the dict equal to true, then we will get our dictionary. So that is the so let's see. So if I put is the resolution 1 is equal to solve express, then resolution 1 is a list. So we can use a list to call that is I call this first, then that is the first result, and when I see the second is I use the index 1, that's the second result. So that is the thing is we can use the list to processing the result. But if we put like this, let's see, so I make is another result with the dict equal to true, then resource this one is our dictionary. So if I put dictionaries, I can see here is let me put this that 1 and 0 is get this dictionary. So when I see the dict is by default is false, then that is directly go to this result. But I can put this here, and I put this dot x, I think. No, is the yeah. I can use this key to get value. So so I can try to see the 0 in the index, and then the x in the as the key. Then I can get the value. So here is the thing is mentioned is the solve function is first import at this one, and we then define symbol and an expression corresponding to the quadratic equation. Then we call solve with the preceding expression at 3. So here the second argument specify that we want the result to be returned as a list of the Python dictionary. So with this one, you also get a list, but it's a list with dictionary as the element. Each solution in return is our dictionary using the symbol as a key, match with its corresponding value. So then that is the way so we can get. And for some these equations, there's no the real number value. Then you get is the complex number, or the we can see here is the you also have the imaginary components. So let's put that is the express equal to x times 2 plus x times 1. Then this solve express get big equal to true. So we get here you see this capital I, that is the imaginary the components, and then this that's the quadratic equations. And let's see. So if you have the multiple the equation the symbol. So let's say from the SymPy import symbols, and then we use this xabc equal to symbols. So we know how we can do this way. So like is xabc. Now we have both as the symbol, and then we create our multiple the symbol expression. So now is a times x is the like is the x squared 2 plus b times x plus c. So express is like this way. Then let's solve. So if I just solve express, so you see here is they will solve A for you. So I don't think it's they have any the order, but looks like it's A is the first one, so it's getting A. Maybe it's let's see. So if I put this expression, so this I put C, this I put A, this I put B. So express. Now also A is first. So that when I do this solve, it's still solve A for you. But actually I'm more interested on the X. So I will put the second argument directly C. I want X. Then they will solve the X for us. So there's two values for X. But it's better is we put this dict to true. So true is the same as the 1. So make that true is we go to our dictionary list. So now we have this symbol value here, symbol here X, and X is represented by this the ABC. So that is the root for the X. So that is the way is we can do here. And then this, if we remember, we can put, let's see, so if I have solved this, whether is I can put this, the result is solve expressed X dict is true. Then result is this one, and the result putting is subs is A3, B5, C4. So those are I see is we should give that is to the express. So now once we have this all this list represent ABC with the value, then we got this X. Then let's see. So now let me solve this to see whether I got and this sub dict equal to true. So it's X. Now X has the those number only value. So and let's do this. Consider an example from physics. This is the distance. And this is the t, so it's the time. Velocity is the u. So and a is the acceleration. So we have such kind of the distance, the formula. So let's try to see what's the solving for that. So we already have a solve, and we just import this pprint. Pprint, and then this SUPA equal to, we use symbols, then this SUPA. So we have one line to define that. Then we define this our expression. Our expression is we should put as move to right, then make that as our equation. So U times T plus 0.5 times A times T, and minus S. Those are our expressions. So let's do this T expression result is solved for T. So expression T dict equal to true. So now let's see. So T express is this one is not looks nice. Now we use pprint. T Yeah, now you can see, so if I put this longer, do this again. Oh, so they have the same, the enter. So now it's at least we can see the from first one. So t is minus u is here is 1.414. So times as times 0.5 u square 2a. So it looks like a kind of a little difference to what we got that. So let's see what's the wrong things. I don't think so. Express t. Yeah. So possible is they put these 2 with the square root go outside. So you can see here no 2, and here has 0.5. So they made some the additional calculation, but fine. That's the result is okay. Now is we have the expression for t. So I refer to this label. We can use the sub method to replace the value of s, u, and a to find the two possible value of t. So then this what we can do is express. We can do here is the express solve like here dot subs with our dictionary. So let's see. So s equal to 200 this one, and u is equal to 30, a equal to 12. I think that's enough. Let's try to see new t. So what's this? Oh, so it should be the dictionary. So sorry, it should be the comma, not assignment. Okay, now let's print print t expr. So now we have this final result with the number. So these ways, whenever you have an expression, you can use a dictionary to send those other values of the variable inside through this subs method. So then you can calculate those results. And then is what if we have two this equation? That is the linear equations, how we can solve that. So let's see. So if we have x, y equal to symbols, so try to familiar with these multiple symbols assigned altogether. So x is x, y is y. So we have two expressions. So one is the 2 times x plus 3 times y. So don't forget about the star. And make that as the equation. So we need to minus 6. Then this equation equal to 0. And another is 3 times x plus 2 times y. And also minus 12. Make that is go to 0. And we can use our parentheses to do the solving altogether. So express 1, express 2, and then give our dict equal to true. So now from here you get our dictionary. So that is interesting is I just get our dictionary, not our list. So this is different to here. So I got our dictionary directly x equal to 24 over 5. Y is minus 6 over 5. 5. So here is also I have x first, y second. So that is the way. So since I already have the dictionary, so I may not need to have the list resolution. So let's see the solution. is here. So solution is a dictionary. So I directly can do this the solutions. Let's see solution the x is that. So I don't need this this index 0 anymore. So that is the thing you may notice there is a difference. We can practice this later to see whether this is the due to this SimPy's new version, the improvement. But what we last have here is once you have your solving solutions, you can put this solution back to the those two equation and to validate or to to check is whether these are real the result. So what we can do is since solution x is the x and solution y is the y, so we can use the express y dot one subs, and we bring this dictionary. So x is the solution x, and the y is the solution y. We check is whether this is equal to 0. So now it's oh, I missed one curly braces. So if it's go to 0, then that means these x and y are the real the solution for the expression 1, and we validate expression 2. If that is also 0, then these are the correct solution pair. So that is the way is we have done the demos for this third part. In a recap is we learned this new the solve that we need to import from SimPy. And then the use that is just a solve with expression, but this expression is actually our the reformed this look like our equation, and then we use this solve to make the solving our quadratic equation. Then we can identify which variable we want to solve using this this chapter. Last but not least, we use this solve to solve our multiple equation. We call this a linear equation. We do our two linear equation, but you can expand that to the more the linear equations. And once you got a pair or the more the results, so you can use the subs and to replace those the variable by your solution, and to check whether your solution is the correct solution. So after that is we solve the finish this 0403 solving equation chapter. And in the next chapter, we will practice the plotting the functions that embedded in SimPy, not from this the plot lib. SimPy itself also including the plotting feature. Then we will try to see how it can help us to make visualization of our this symbol and the symbolic mass. See you then.